Hello everyone, this is Teacher Harold, your junior high school math teacher. And in this video, I'll discuss the second lesson about variations, particularly how to translate a relationship between two quantities to variation statement. So after watching this video, you should be able to translate a relationship between two quantities in variation statement by table of values, mathematical equations, and graphs. You are also expected to answer related questions, and of course you are also expected to participate actively during the discussion. In the previous material, learners or you were able to illustrate situations that involve variations and were able also to determine the type of variation from the given situation. In this material, we will have the continuation of the previous topic with the discussion on how to translate the relationship between two quantities into variation statement or mathematical statement, as well as answering some questions related to this concept. Now let us start with direct variation, particularly direct linear variation. It is the relationship between two quantities such that an increase in one quantity produces a corresponding increase in another quantity, or a decrease in one quantity produces a corresponding decrease in another quantity. In other words, if we use symbols for the quantities involved, say one quantity varies directly as the other quantity, or one quantity is directly proportional to the other quantity, in symbol where x and y represent the two quantities, then we could translate any of these two statements using the constant of variation k. So y varies directly as x, or y is directly proportional to x. In mathematical translation, we have y is equal to kx, where k, if we solve this equation, is equal to y over x. And again, where k is known as the constant of variation. Or we can also say that this is the constant of proportionality. Okay? Next. Let's take, for instance, if the distance d varies directly as the time denoted by small letter t, then in mathematical symbol, the translated statement would be what? D is equal to kt, where k is again the constant of variation or the constant of proportionality. Likewise, if the distance d varies directly as the rate r, then in symbol, that the statement is translated into mathematical equation, and that is d is equal to k times r. Take for example, the table shows the distance d in kilometers traveled by a car in t hours at a speed of 60 kilometers per hour. Now let us consider this table of value. The first row of values is represented by the time t in terms of hour, and the second row of values are the distance in kilometers represented by small letter d. Say after 1 hour, the car already traveled 60 kilometers. For another hour that has passed, the car already covered a distance of 120 kilometers. Another hour, the car already covered a distance of 180 kilometers. And after another hour, the car already covered 240 kilometers. So we can say that from this table, the distance d varies directly as the time t. In symbol, that is d is equal to k times t. And k, transforming this equation, solving for k, is equal to d over t. Particularly, the value of k is 60 kilometers, which is the rate or the speed of the car. And the equation of variation is what? D is equal to 60 times t. Now, how did we form this equation of variation? Actually, it is taken from this translated equation, wherein k here is replaced by the value 60. So that the equation would be like this: d is equal to 60t. And using that equation, suppose a car continues to travel. Now, what would be the covered distance of the car after traveling for 7 hours? Now, making use of this equation of variation, we can get the distance covered by the car. And we simply substitute the value of t, which is equal to 7, and simplify this right side of this equation. And that is 60 times 7, or that is 420 kilometers. Okay. So this is the distance already traveled by the car after traveling for 7 hours. Okay. Next. Now let us now consider the graph of this particular situation. So looking at the graph for this particular type of variation, whose equation is d is equal to 60t, notice that it is actually a straight line that rises from the origin to the right and has a slope of 60. So, okay, so this is the y-axis or the vertical axis, and this is the horizontal axis. Now, the coordinates along this axis are actually the distance in terms of kilometers, and the coordinates along this horizontal axis are the time in terms of hours. Now, using the table of values and plotting those ordered pairs to this Cartesian plane, okay, so 160 taken from the table, 2, then 120, 3, 180, 4, and 240. Now, the plotted points are actually contained in a straight lines. So, if we're going to connect these 4 plotted points, you will notice that the graph is a straight line which is drawn from the origin, rises up, having a slope of 60. So lumilitaw class, this direct variation has a graph which is the same as the graph of the linear function of the form y is equal to mx plus b. Since b here is equal to 0, and we know that from the linear function, b is actually the y-intercept. Okay? So basically, the graph of direct linear variation is a straight line drawn from the origin, and the line rises to the right. Okay? And this is the equation. A linear function. Okay? Having a slope of 60, and of course the y-intercept is at 0 coordinate. Next. Let us have the second example. If y varies directly as x and y. Okay, if y varies directly as x and y is equal to 36 when x is 12, find the equation of variation and the value of y when x is 108. So, for our solution, basically, you need to translate this statement. Y varies directly as x. This one. So if we're going to translate this to mathematical equation, we need to insert the constant of variation k. And the equation would be like this. Y is equal to k times x. And solving for k, we have k equals y over x. And to solve for the value of k, we use the initial values of y and x, or x and y. And that is what? 36. And for the value of x, it's 12. So these two values here are to be plugged into this equation in order to find the value of k. And that would be what? K is equal to 36 over 12, or that is k equals 3. And then, upon getting the value of k, we can now form the equation of variation. Taken from this translated mathematical equation, we replace k by 3 so that the equation, we replace k by its value 3, so the equation becomes y equals 3x. And upon forming, or after forming the equation of variation, we can now compute for the required unknown, since the final value of x is given as 108. So the problem is asking us to compute for the final value of y. So basically, taking this equation and substitute the value of x as 108, we can compute for the corresponding final value of y. And that would be what? Y is equal to 3 times x, which is 108. Therefore, the value of y is 324. Next, we go to the next type of direct variation, and this is the direct square variation. Now, there are many situations where one variable varies directly as the square of the other. For example, the area of a square varies directly as the square of its side, or the distance of falling body is directly proportional to the square of the time traveled, provided that we neglect the resistance of the air. Now, these situations are examples of direct square variation. Now, suppose if y varies directly as the square of x, this statement is translated using k as y equals kx squared. And of course, k there is the constant of variation. And transforming this equation, solving for k, therefore k is equal to y over x squared. Again, k equals y over x squared. Okay, let us take some examples. Suppose if y varies directly as the square of x and y is 27 when x is equal to 3, what would be the value of y when the final value of x is 7? So for our solution, translating this statement right here, y varies directly as the square of x. So by using k, so we have y is equal to kx squared. And from the translated equation, solving for k, we have k equals y over x squared. And using the initial values of x and y, we can compute for the value of k. Okay, this one, we use this so that we can compute for k, and we use the initial values of x and y. And what are those initial values of x and y? So first one is y is 27 and the x is 3. So plugging in these two values to this equation, the value of k can be computed as 27, which is your y, over x, which is 3 squared. And simplifying this side of this equation, k is what? 3. Then, going back to this translated mathematical equation, we can now form the equation of variation. So, taking this equation, we simply replace k here by its obtained value. And the obtained value is what? 3. So that the equation would become y equals 3x squared. Yeah. And from this obtained equation of variation, we can now compute for the required unknown if the final value of x is given as 7. So for the final value of y when x is 7, using this equation of variation, we have y is equal to 3 times x, which is 7, squared. So if we're going to simplify this, we have the value of y, which is 147. Now, for our next illustrative example, suppose we have a table of values showing the distance that an object falls varies directly as the square of the time the object has been falling if we neglect the air resistance. So the distance is denoted by small letter d, while the time the object has been falling is denoted by small letter t. So if an object falls in 36 feet in 2 seconds, determine the following: the constant of variation, the equation of variation, the distance in feet in feet, it will fall in 4, 6, and 8 seconds. And D, show the graph of this type of relationship between the distance D and the time. So we prepared a table of values. So the first row of values is represented by the time t in seconds, and the second row of values is represented by d in feet. So after 2 seconds, the object falls by already falling by 36 feet. So after 4 seconds, the object has been falling by how many feet? O sige, tuloy natin. So let us consider answering letter A, the constant of variation. First is we translate the statement. So let D is equal to K T squared. Because right here, D, the distance D, the object falls, varies directly as the square of time. This one right here is being translated into this equation using K. Yeah. Now, using this equation, the translated equation, we can answer the following, beginning with A, the constant of variation. So, transforming the equation, solving for K, so that is equal to D over T squared. Now, for the constant of variation, we use the initial values of D and T. And what are the values? Yon. D is 36 and T is 2. So, ito yun. So, if we're going to simplify this, 36 over 4, your K is 9. And upon obtaining K, we can form the equation of variation. So again, we go back to this equation and we simply replace K by its obtained value, which is equal to 9. Therefore, D from this equation is equal to 90 squared. Okay. Again, we simply copy this one. The only difference is K is replaced by its value, which is 9. And this is the equation. And for letter C, the distance, the object fall in 4, 6, and 8 seconds. So if the time is 4 seconds, now how far does the object fall? So that is, we make use of this equation. So replace T by 4. So this is already the expression. And you simplify that, it's 144 feet. Now, after 6 seconds, the same equation, but this time your T is 6. Then simplify the result. So, after 6 seconds, the object already falls by or already fell by 324 feet. And after 8 seconds, the object has already covered 576 feet. Ayan. So, these are the answers. Then for letter B, I think we are asked to graph the equation D is equal to 90 squared. So we have a portion of a parabola in quadrant 1 that opens upward and whose vertex is at 0, 0. So that explains the appearance of the graph. So when we talk about direct square variation, particularly when it comes to its graph, it is actually the half of the parabola that opens upward, and half of that graph is situated in quadrant 1, which is drawn from the origin like this, no? So, yeah. So, if we're going to plot those points, you will see that this is the graph, which is half of the parabola. Yeah. Next, for the inverse variation, it is the relationship between two quantities such that an increase in one quantity produces a corresponding decrease in another quantity, or vice versa, and vice versa. Okay? In other words, one quantity varies inversely as the other quantity, or one quantity is inversely proportional to the other quantity. In symbol, if the two quantities are again represented by x and y, Then y varies inversely as x, or y is directly proportional to x. Now, any of this statement can be translated to mathematical equation using k. Yan. So, y is equal to k over x, where your k is simply the product of x and y. So, you just do the cross multiplication. And again, k is still known as the constant of variation or the constant of proportionality. Okay? Let's take some examples. Number 1, if y varies inversely as x and y is 4 when x is 3, find the value of y when x is 9. So, we simply translate this statement, y varies inversely as x, by using k, or the constant of variation. So that would be what? Y equals k over x. And from that equation, k is the product of x and y. Now, using the initial values of x and y, we can compute for k. Yun. And the initial values of y is 4, while x is 3. Okay, using these values, we plug in these two to this equation, then we can compute for k. So k is equal to xy, or k is equal to 3 times 4, which is 12. Then, after getting the value of k, we can form the equation of variation by going back to this translated equation. We copy this, and we replace k by its obtained value, and that is 12. So that the equation becomes okay, y equals 12 over x. And this is the equation of variation. And from that equation, we can now solve for the required value of y, since the final value of x is given as 9. Okay. So from this equation, we just plug in the value of x right here and simplify the result. Therefore, your y is equal to 4 over 3. Yan. So this is the value of y when the final value of x is 9. Illustrative example. Which of the following tables expresses inverse variation? For the table that expresses inverse variation, determine the constant of variation and the equation of variation, and then draw its graph. Okay. So this is the table of values in letter A, while the table of values in letter B. So let us investigate. Now, for our solution in letter A, does letter A expresses inverse variation? So the answer is yes. Why? Since k, the constant of variation, is the product of the values of x and y. So if we're going to use the pairs of x and y values, we get their product. It's 24. Okay, 12 times 2 is 24. 3 times 8 is also 24. 4 times 6 is also 24. So this table of values expresses inverse variation. Now, what about letter B? Is it also expresses variation? Is the table of values in letter B expresses inverse variation? Okay. Now, before we go to A, okay, ang pinapahanap pa, since this table is an inverse variation, we are also asked, not just to find the value of k, but also the equation of variation. So we know that k is equal to xy, therefore 24 is equal to xy. And this is actually the equation of variation. Okay? Yun. Actually, this one. Y equals 24 over x. Next. What about letter B? So the table in letter B does not express inverse variation. Why? Because if we check the product of each pair of x and y values, the value is not constant. Okay? Since 6 times 3 is 18, 7 times 15 is not 18, neither 8 times 45 is also not the same as the product of these two. Okay? So, hindi constant yung product ng x and y. So, letter B does not express inverse variation. Now, for its graph, you will notice that the curve is asymptotic with respect to both x-axis and y-axis. Such graph indeed represents inverse variation. So, for you to visualize what the product, what this paragraph, uh, what this product is talking about, so this is the graph. Yun. So, indeed, the graph of inverse variation is asymptotic with respect to the x and y axis. When you say asymptotic, the graph will just simply approach either x and y axis, but the graph will never touch any of these two coordinate axes. Okay. And this is the equation, this is the graph. And okay. So I think that would be all for now. See you next time.